Hello friends, welcome to this new video. In this video we'll learn about some MCQs of chapter 2 of class 10th, that is polynomials, and this video is dedicated for the students who are in class 10th and are going to give exams in next month uh, of boards, that is of objective type problems that are coming in that board. So we will discuss some objective type questions. Here's problem 1, um, which says which of the following is not a polynomial. In this problem, uh, there are four options. We have first option is 3x plus 5, second option is 3y cube minus 4y square plus 2y, and third option is x cube minus 3, and fourth option is 1 upon x plus 2. And in this question asks that which of the following options is not a polynomial. So this, we see the solution here. The solution is 1 upon x plus 2 is not a polynomial. But why? Why 1 upon x plus 2 is not a polynomial and others are polynomial? Since the exponent of variable is negative. Here we can see x plus 2 to the power minus 1. Then we can see that the exponent of the variable is negative, is not positive. So 1 upon x plus 2 is not a polynomial. So for a polynomial, the exponent of variable should be positive, not negative. Here the in option 4 the exponent of variable is negative, so option 4 is not a polynomial. Now we'll see problem 2, which says if 2 is a 0 of a polynomial, fx is equal to ax square minus 3a minus 1 x minus 1, then the value of a. In this question, given that 2 is the 0 of polynomial, then what is the value of a of this in this polynomial? And the options are 4 upon 3, minus 4 upon 3, 5 upon 2, and 1 upon 2. And let's see the solution of this problem. Here, given that fx is equal to ax square minus 3a minus 1x minus 1 and 0 and 2 is the 0 of polynomial. Here we can see, given that 2 is the 0 of polynomial, then what is the meaning of this? What is the meaning of 0 of polynomial? Meaning of 0 of polynomial is that if we put that value in the polynomial, then we will get the value of the function of polynomial, that is 0. So if we put 2 in the polynomial here at the place of x, then we will get a. At x we will put 2, then 2 square minus 3a minus 1 into x cube. We'll put x, we'll put 2 at the point of x minus 1. Then we know that if 2 is 0 of polynomial, then f of 2 is 0. So we'll put f of 2 is equal to 0 and solve this equation. Then we'll get 2a is equal to 5 and a is equal to 5 by 2. That is option number 3. So in this problem we learned the concept of 0 of polynomial. That's the most important topic of this chapter. So we should know what is the meaning of 0 of polynomial. Now we'll see problem number 3. That is the graph of quadratic polynomial is. The question asks what is the graph of quadratic polynomial, and we have option as straight line, parabola, hyperbola, and none of this. So we can see the graph of x square, that is a quadratic polynomial, and we can see that it is a parabola, and we should know that the graph of a quadratic polynomial is always a parabola. So the option number 2 is correct. Parabola, the graph of quadratic is always a parabola irrespective of values of x and y. Then what is the value of x and y? That does not changes the graphs. The graph is always a parabola. Now we'll see problem number 4, that is the zeros of quadratic polynomial x square plus 5x plus 6 are. In this question, the question asks that what is the 0 of this polynomial, and the option is minus 2 and minus 3, 3 and 4, 3 and 2, and 2 and 4. Let's see the solution. Given quadratic equation x square plus 5x plus 6, the quadratic equation is given and we have to find the zeros of this equation. Then we'll put x square plus 5x plus 6 is equal to 0. The zeros means what is the value of that the zeros. We'll put the zeros in the at the place of x in the polynomial, then we'll get the value of polynomial as 0. Then we'll solve this equation by splitting the splitting method. We'll put 5x as 3x plus 2x, and we can say 3x into 2x, that is 6x square, that is multiply of 6x square, and we'll take common x in x square plus 3x, and we get x plus 3, and we'll take 2 as common in 2x plus 6, and we'll get x plus 3, and we'll get x plus 3 and x plus 2, that is equal to 0, and we'll after solving this we'll get x is equal to minus 3 and x is equal to minus 2. So the zeros of polynomial are x is equal to minus 3 and x is equal to minus 2. We can check it also. If we will put x is equal to minus 3 and minus 2 at this equation, let's put x is equal to minus 3 here. Minus 3 square plus 5 into minus 3 plus 6, that is 9, minus 15 plus 6, that is 9 plus 6 15, minus 15 is equal to 0. Now let's check about minus 2. Let's put minus 2 in the value at the value of x. Minus 2 square plus 5 minus 2 plus 6, minus 2 square, that is 4, minus 10 plus 6, 4 plus 6 is equal to 10, minus 10 is equal to 0. So we can also check our answer after putting the value of x and in the of zeros at the value of x, and if we are getting 0 after putting the values of zeros in the polynomial, then the zeros are correct. Let's see next problem, that is problem number 5. In this question, the question says 0 of pz, z square minus 27r. In this question, another quadratic polynomial is given, and we have to find the zeros of that polynomial. And the first option plus minus 3 root 3, second option is plus 3, and plus 9 is the third option, and none of this is fourth option. And let's see the solution. Let's put the polynomial is equal to 0. Pz is equal to 0, z square minus 27 is equal to 0. Then let's transpose minus 27 in right hand side. Then z square is equal to 27, and then z is equal to plus minus 3 root 3. After putting these values in the at the place of z, we can check the answer. Then plus if we put plus 3 root 3 or minus 3 root 3, both the values square is 27 and minus 27 is equal to 0, then these are the correct options and first option is correct. Let's see problem number 6. The problem 6 says the number of polynomials having 0 as minus 2 and 5 is. This question asks how many polynomial you can find that have zeros as minus 2 and 5. That's a good question, and the option is 1, 2, 3 and more than 3. Let's see the solution. The equation of quadratic polynomial x square, we know that the equation of a polynomial is x square minus 2 minus sum of zeros, the zeros which are given, the sum of zeros into x, the product plus product of zeros. It means if the zeros of a polynomials are given, then we can find the equation. But how? If the zeros are given, we get the sum of the zeros as minus 2 plus 5, that is 3, and we get the product of zeros minus 2 into 5, that is minus 10, and we'll put the sum and product in this, and we'll get x square minus 3x minus 10. So that is the equation we'll get after the zeros are given to us. So that's also an important formula we'll get here, and an important topic we learn here. The sum of zeros is that, and the product is that, and the equation is that we learned here. Now we know that if we multiply or divide a polynomial with any arbitrary constant, then there is not any change in the solution or the zeros of that polynomial. It means if we multiply or divide, then there is no any change in the zeros of that polynomial. So if we multiply by any k that is a constant number, or divide in this equation, then their zeros is again minus 2 and 5. This is not changing any zero, so we can get as many as polynomial. We can multiply as many as number in this equation, and we can get as many as polynomials. So the number of polynomials having 0, minus 2 and minus 5 is more than 3, that is infinite. Problem number 7 says every real number is zeros. Every real number is zeros of a zero polynomial. Then what is zero polynomial? Zero is a zero polynomial. Then in a zero polynomial, if we put any value, we'll get 0. Any value, what value you can think, any value if you put in that polynomial, you will get 0. So that's true. If every real number is zeros of zero polynomial, if you put any real number in a zero polynomial, we will get a 0. So that's true. Every real number is zeros of the zero polynomial, hence the answer is true. In problem number 8, we'll see if alpha and beta is the zeros of quadratic polynomial. A quadratic polynomial is given and alpha and beta are zeros of that polynomial. The value of a is minus 12. The value of a here is minus 12 if 3 alpha plus 2 beta is 20. And we have to check it. Is it true or false? We have to check that a is really minus 12 or not. If 3 alpha plus 2 beta is equal to 20, where alpha and beta are zeros of a quadratic polynomial. This. Let's see the solution. We have seen that the answer is false. Let's see how. We know that if alpha and beta are zeros of polynomial, then f alpha is equal to f beta is equal to 0. If we put alpha here in this equation, we'll get alpha square minus 6 alpha plus alpha is equal to 0. If we put beta here, then we'll get beta square minus 6 beta plus alpha is equal to 0. Sorry, here's a mistake. Here alpha, that's not alpha, that's a. Let's change it. Here alpha is not alpha, it is a. And we know the sum of the zeros is that let's say his alpha and beta 0, then alpha plus beta is equal to minus b by a. Minus, you know that his minus b is equal to minus b. Here b is equal to minus 6, then minus of minus 6, that is 6, and a is 1, that is 1. So here we get alpha plus beta is equal to 6. And we know that 3 alpha plus 2 beta is equal to 20, that is given here. Then solving both the equation, we get alpha is equal to 8 and beta is equal to minus 2. You can solve by substituting or elimination method. Let's put beta square minus 6 beta plus a is equal to 0. We know that from here. Let's put beta here. Then after putting beta here, we can substitute here a is equal to 6 beta minus beta square. And we know that beta is equal to minus 2, that is 6 into minus 2 minus 2 square, that is minus 12 plus minus 4, that is minus 16. And here's a mistake, that is minus 16 is the answer and 16 is written here, so sorry for that. And we can see that it is given that a is equal to minus 12, but after solving this problem, we get a is equal to minus 16. Let's see problem number 9, that is if p and q are zeros of a polynomial 3x square plus 9x plus 9, then value of p minus q. Here given that p and q are zeros of this polynomial, then we have to find p minus q. Here we should know some concepts. That is sum of if alpha and beta are zeros of a polynomial, then alpha plus beta is equal to minus b by a. If zeros of that polynomial, then alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. And we should know another concept, that is x plus y square is equal to x square plus y square plus 2xy. That is that we know that x plus y square is equal to that. And if we subtract minus 4xy from this, we'll get x square plus y square minus 2xy. That is x minus y ka whole square. Let's see the solution of the problem. If we know that p plus q is here minus 2, that is minus b, that minus 2 by 3, and p into q is minus 9 upon 3, that is minus 3. and we know that p minus q का whole square is equal to p plus q का whole square minus 4xy. P plus q का whole square, that is this, minus 4xy. And if we have to find p minus q, that is under root plus minus under root p plus q का whole square minus 4xy. And we know that p plus q is equal to minus 2 by 3 and p into q is equal to minus 3. Then minus 2 by 3 का whole square minus 4 into minus 3, that is under root 4 by 9 plus 12, that is plus minus 4 root 7 by 3. That is option number 3. Let's see problem number 10, that is the last problem in this video. And here the problem given that if alpha and beta are zeros of this polynomial, then what is the value of 1 upon alpha plus 1 upon beta? We know that if ax square plus bx plus c, and if alpha and beta are the zeros of this polynomial, then alpha plus beta is equal to minus b by a, and under alpha into beta is equal to c by a. Here alpha plus beta is equal to minus 3 by 4 and alpha into beta is equal to 7 by 4. And we have to find 1 upon alpha plus 1 upon beta, that is alpha plus beta. If we take LCM here, we get alpha into beta, and we'll get here beta plus alpha, that is alpha plus beta upon alpha into beta. And we know that alpha plus beta is equal to minus 3 by 4 and alpha into beta is 7 by 4, and after putting this value we'll get minus 3 by 7. That is the answer, that is option number 2. I hope you liked the video. Thanks for watching this video, and please like, share and subscribe with your friends. Thank you.